Good morning, class. My Screencastify program is now on um, whatever. It's not working right now, so I'm going to try it this way, and hopefully this works to record this meeting. So right now I'm going to present my screen so I can go show you our lesson for the day. Okay, so chapter, I think we're in 6. This is lesson 4, and we're going to start talking about combinations. So previously we were talking about permutations and combinations, and basically what you know to be combinations are usually permutations because permutations require an order. So for example, that combination lock that you have, that's the little padlock that you dial in numbers, you go 36 and then back to 4 and then forward to 11. That is actually a permutation because 36, 11, and 4 is the combination lock, but those numbers have to be put in that order. Now, my discussion is always because my niece thinks that the way you order a taco makes a different tasting taco. So she believes that if you could put the same ingredients on, but in a different order, you have a different taste. I think put it all on, you roll it up, you stuff it in your mouth, you take a bite. Doesn't matter if the sour cream is next to the cheese or next to the meat or whatever. So I would have many fewer tasting tacos because I think order doesn't matter. So mine is a combination where hers is a permutation. Think of all the different kinds of tacos you could have then if you thought that the order created a different tasting taco. So just sample, I'll have to ask you whether you're doesn't matter, layer it all on, who cares, or if you like it in a specific order. Okay, so this example says as part of the grade 12 English course, students are required to read the following 3 books in a 3-month period: The Grapes of Wrath, The Wars, and the Bean Trees. Just for clarification here, we're gonna call this G, W, and B. Okay, due to previous late terms or returns, Steve is only allowed to sign out 1 book from the school library per month. List all the different orders in which you could sign out the 3 books. So that's not hard. This would be like, if you had a series and the series mattered which way you read the books in, had different understanding, but maybe 3 separate books totally unrelated and it really wouldn't matter. That's what we need to be talking about when we talk about perms and comps. Okay, I'm not going to go with B, G, W. Okay, so we have 3 books read in different orders. There's a total of 6 ways. All right. Tarek is allowed to sign out all 3 books at the same time. How many different? He can only sign them out 1 way, guys. Send them all out today. Doesn't matter which way he signs them. So part A is an example of a permutation where order is important, and a combination is where order is not important. Okay, so if we talk about selecting things, order isn't important. Arrangements is a permutation word. Suppose that the students in part 1 were required to read only 2 of the books. Okay, so if we just did our combinations here that we had up there, we could have, the Wars and the Beans. We could have the Beans and the Grapes of Wrath. We could have the Beans and the Wars. I think that's all we could do. But if you notice, for this guy, he's got different ways to do it, but these are the same things. Here's a Grapes of Wrath. This is a G and a B. Oh, that's the same as this one over here. And then we have the Wars and the Grapes. The Grapes of Wrath. Yeah, and then we have, here they are. The Wars and the Beans right there. Yeah. So while he has 6 ways, he only has 3 ways. So there's not as many different combinations. The number of combinations is equal to the number of permutations divided by 2, which is 2 factorial. So you can take a permutation, and if you just divide it by the ones that are the same, you get back to a combination. So a permutation is an arrangement. We're going to learn that. And a combination is a selection. Okay, turn the page. So what happens over here is 5 students, Al, Byron, Colin, Dave, and Eric, take part in a cross-country race to represent their school. Suppose the winners of the race wins 50, runner-up wins 25, and the 3rd place wins 10. Okay, this is a situation where the order you were in mattered. right? So we have all the different ways that the prizes could be awarded. This is a 5P3. We have 5 people and we're arranging 3 of them. There's a lot. So this is an example of a permutation because the order matters. How many ways are there to award the 3 prizes? Well, that 5P3 thing is 60. You could also use it doing the slots. You could go 5 times 4 times 3. The other way to do it, either of these ways is acceptable, and you would get 60 different ways. Now, for participating in the cross-country race, the school has been awarded 3 places at a running clinic. Okay, we're just going to a clinic. Order doesn't matter. It doesn't matter how you get on the bus. You're not going to get to a different clinic or get a different award just by getting on the bus and going to the clinic. 3 lucky students get to go. All of a sudden, we have all these things that are the same. These are the same 3 people. Doesn't matter what order they get on the bus, right? Etc. So they're all the same. So all of a sudden we have combinations because order doesn't matter. And now there's only 10 ways to get all 3 students. So way less combinations if we're just picking any 3 students. So the number of combinations is equal to the number of permutations divided by, well, 6 in this case, which is the same as 3 factorial. So you will see here that from the examples we did, that a combination, which by the way is on your calculator, is the number of permutations divided by however many you're choosing here, is R factorial. So it turns out to be a new formula in this order, noticing that the new part is this piece. The rest of it is the permutation formula. So this is the permutation formula that you remember before, but now we're going to divide it in by a little bit more because there's fewer combinations. Okay, it's on the calculator button. Again, you would hit, you have to first type in your N. Okay, so we were trying to do 7, choose 2. You would type in 7 on your calculator. Then you would go to the math button. And I choose the back arrow on my Game Boy key to get to the PRB. You're trying to get to PRB. And then you would go down and choose the 3, which then gives you the N, choose R. And then you have to type in the 2. Okay, so a few keystrokes there. On your calculator, in the end, it would look like this. That's what it's going to look like on your calculator. Okay. So there's another notation though that you need to know in here, and that is that it can be written with big parentheses, and there's no line in between, so it's not a fraction, but that notation also is the same as saying it's a combination. We'll hang on to that text, that note. Okay, 3 students from a class of 10 are chosen to go on a school trip. In how many ways can they be selected? There's that word that's just going to imply that you do combinations because we don't care which arrangement they're in. Write the answer in factorial notation and evaluate. So we're going to say, okay, I have 10 kids. I need to choose 3 of them. That becomes this. And it's 10 minus 3 factorial and then 3 factorial. So you get like that. And when you type it all in your calculator and divide carefully, being sure that when you use your calculator, you put this bottom in brackets, and you'll get 120. You should try that. Okay, and you can, of course, go use this calculator key on your, if you want to. Okay, class example 2. To win the Lotto 649, a person must correctly select 6 numbers between 1 to 49. Okay, selection is not the same as arrangement. Doesn't matter which way you pick the numbers. Jasper selected the 6 numbers from the birth dates of his family. How many different selections of numbers could he have made? Okay, so this is a misleading. We don't have to worry about those numbers at all. What we have is 600, we have 49 numbers from which you need to choose 6. So when he was all done, here were his chances. 13,983,816 ways of choosing 6 numbers from the 1 to 49. So good luck on your options. The athletic council decides to form a subcommittee of 7 council members. Okay, pay attention. 7 council members to look at how funds raised should be spent on sports activities. There are a total of 15 athletic council members, 9 males and 6 females. The subcommittee must consist of exactly 3 females. All right, so you have to have 3 girls, and then the other part of the 7, remember there's only 7 going to be on this new committee. The rest of them have to be boys. So they're going to break it down for us. It says, first, let's figure out the way of getting the girls. So there are 6 girls in total, and we need to pick 3 of them or choose 3 of them. So we could get 20. Now the ways of getting the males, there are 9 males. And remember, we need 4 of them because we're going to have 3 females. So we need 4 males. And when you put that in your calculator, you get 126. So the subcommittee needs these females and it needs the males. You're going to times those together. And that will be your number. Okay. All right. Now here comes some little stipulations or regulations. It says, all right, in how many ways can the subcommittee be selected if Bruce, the football coach, must be included? So we still have 7 people. We have to have 3 girls, which would include 4 boys, but I already have 1 boy coach. So I have 1 male already on. So I only need 3 more boys. Right? Make a little list of what you need to have so you can be sure. So to get your 3 girls, it's the same. I have 6 women. I need 3 of them. But now I already have a boy on the team. He's been sent to get on the bus already. He's already there. So not only does that mean I have to choose fewer boys, but it means I have fewer boys to choose from. So this 9 males goes down to 8. So I have 8 males from which I need to pick 3 because the coach is already on the team. Okay, so that becomes 20 times 56. All right, good stuff. Next question. Okay, a standard deck of 52 cards. There's lots of 52 card questions, standard deck questions. So you have to really be familiar. I was not familiar with cards. I never grew up playing cards. So I was lost when I started, when I met Lauren, his family plays tons of cards. So I learned, but you kind of have to keep it in mind. So this might be something that you need to highlight and come back to. You have 4 suits, spades, clubs, diamonds, and hearts. Each suit has 13 cards. 2 of them are black, 2 of them are red. And your face cards are considered jacks, kings, and queens. Okay, so make sure you know that information. Poker is a card game played from a deck of 52 cards. How many different 5-card poker hands are there? Okay, so doesn't care which cards you've got in there. I just need 5 cards in my hand. So 52, order is not important. You can rearrange them once you pick them up, and that's what you've got. You have 52 cards, of which you are choosing 5. So you have this massive number. Once again, this shows you some of the chances of getting a good hand. 2,598,960. That 2 looks a bit disconjuncted. Okay, that was the easy one. Now, in how many of the hands will there be? Okay, of all of these hands, how many will there be all diamonds? Well, to be all diamonds, straight diamonds, you need, of the 13 diamonds, you need to pick 5 of them. So 1,287 cards, hands, would be all diamonds. Okay, now, out of all of those 2.6 million almost different cards or different hands, how many will be 4 black cards and 1 red card? Okay, so I need 4 black and 1 red. Well, half of them are black. So that's 26. Choose 4. And it's an and. I need 1 red. So I need 26 red, of which I need to choose just 1. Big numbers. All right. How many will be 3 kings and 2 queens? Okay, so here's where you have to start thinking a bit. There are 4 kings and queens in the deck because there's 1 of each suit. So there are 4 kings, of which I must choose 3. And I'm going to times, there are 4 queens, of which I must choose 2. That is 5 cards in my hand. There's only 24 of them. 24 out of 2.6 million hands. have 3 kings and 2 queens. All right. What about if it just wants 3 kings in total? We don't care what the other cards are, just 3 kings. So I have 4 kings, of which I need 3 of them. The other 2 cards don't matter. So, okay, so here's 4 kings and 2 not, or anything else, right? I'll say anything else. Now, not kings, they can't be kings. So I have to take my deck of cards. I have to pretend that I'm taking the kings. I'm dealing with those separately. So 52 minus the 4 I don't want leaves me with 48 cards, of which I need 2. Because I need to have 5 cards in my hand. Okay, what if you want 4 aces? That means I want 4 aces and 1 of anything else, right? So make yourself a little chart so you know. So to get the 4 aces, I need 4. I need all of them. And then I'm going to pick the 48 other cards, of which I need 1. My answer there will be 48. What if you want 5 cards of the same suit? Ooh, that means I could have 5 clubs, 5 diamonds, 5 hearts, or 5 aces. Okay, or 5 spades, sorry. Okay, that's your options. So to get 5 clubs, I would have, there's 13 of each suit. So that's what I'm going to do. And then I could say, or 13, choose 5 to get the diamonds. Or, so there's another way, just there's going to be 4 different things that are 13, choose 5. Instead of adding, I could just times it by 4. So when you do that, you will get 5,148. So to get a flush, apparently, if you're a poker person, there's 5,148 different options. Okay, good luck. Hope that works for you. Hopefully you can read this.